The foundations of strength. Why buildings stand the test of time. Have you ever walked past an ancient building and wondered how it stood for centuries? It's incredible, isn't it? The Colosseum in Rome, for example, has stood for almost 2,000 years. Understanding why some buildings last and others crumble is crucial, not just for architects and engineers, but for everyone. We live and work in these structures. Our safety and well-being depend on their integrity. A building is only as strong as its foundation, and that starts with understanding the ground it stands on. Just like a house needs a strong foundation, a skyscraper needs to be anchored to solid ground. Ignoring the soil composition is a recipe for disaster. Think of it like building a sandcastle on the beach. Without a solid base, it won't last long. Cracks appear when buildings falter, and why? Cracks in a building are like warning signs. They tell us something is wrong. Sometimes the problem is obvious: cheap materials, rushed workmanship, cutting corners. Other times it's what you don't see that's the problem. The ground beneath, shifting and settling, putting stress on the structure above. Imagine building a brick wall. You wouldn't just pile the bricks on top of each other, would you? You'd need mortar to hold them together, to distribute the weight evenly. The same goes for a building. Steel beams, concrete columns, they all work together like a well-built wall to support the load. But if the ground shifts, or the materials are subpar, or the design is flawed, cracks will appear. These aren't just cosmetic issues, they're signs of deeper problems that could compromise the entire building. Building for eternity: key elements of enduring structures. So how do we make buildings that last? It starts with the right materials. Think of it like baking a cake. Use cheap ingredients and you'll get a lousy cake. Use quality materials and you're on your way to a masterpiece. Next, we need a solid plan. A good engineer is like a conductor, making sure every part of the orchestra is in sync. They understand the soil, the materials, the weight distribution, and design a structure that can handle it all. Soil analysis. Before laying the first brick, we need to know what's below. Soil testing reveals the ground's composition, its ability to bear weight, and potential issues like water tables. Material quality. Just like you wouldn't build a house with rotten wood, we can't build lasting structures with shoddy materials. High-grade concrete, steel, and timber, all chosen for their strength and durability, are essential. Engineering design. A well-designed building is like a well-oiled machine, every part working in harmony. Engineers use their knowledge of physics and material science to create structures that can withstand the test of time. Finally, it comes down to craftsmanship. Even with the best materials and design, sloppy work can lead to problems down the road. We need skilled tradespeople who take pride in their work, ensuring every detail is done right. The last brick laid a foundation for knowledge. We've seen the good, the bad, and the ugly when it comes to building construction. Understanding why some buildings stand tall while others crumble is crucial for everyone, not just industry experts. When we understand the importance of soil analysis, material quality, and sound engineering, we can make informed decisions about the spaces we inhabit. So the next time you admire an old building, or cringe at a crack in the wall, remember, buildings are more than just bricks and mortar. They're a testament to human ingenuity and a reflection of the care and attention to detail that goes into their creation.